Hello, everyone. My name is Xiong Zhen. I'm from Taiwan Network Information Center. It's my great pleasure to chair the IPv6 Readiness Measurement BoF. And first of all, I'd like to welcome all of you to participate in this BoF meeting. And I also like to thank Miwa for her arranging this BoF meeting and co-hosting this meeting with the IPv6 task force. You know, both of us are interested in the same thing, but the BoF is more focusing on the readiness measurement and the criteria. So today, I'm very happy we have invited 4 speakers. And for the sake of time, I'd like to suggest each speaker will have 12 minutes for presentation, and therefore we can have 3 minutes for discussion. So the first speech is Japan IPv6 measurement, and it will be presented by Fujisaki-san from NIT. Fujisaki-san, please.
Okay, let me start. Good evening, everybody. My name is Tomohiro Fujisaki, working for NTT, and here also is the head of the IPv6 Promotion Council Japan. Okay, let me start on my presentation. And this is summary of IPv6 deployment status in Japan. And for the network point of view, many ISPs, many fixed-line ISPs have started their commercial IPv6 service for both enterprise and consumer users. And also, some ISPs have been migrating their existing IPv4 only users to dual stack environment. So in Japan, total IPv6 users are increasing. But unfortunately, not so many cellular carriers provide IPv6 connectivity, and they provide IPv6 by optional. So in the cellular point of view, in Japan, the IPv6 user is not so many. And from the content side, IPv6 ready government services are increasing. But in Japan, large content providers do not support IPv6 yet. This is a summary of IPv6 status in Japan. Okay, in the next few slides, I explain the Japanese IPv6 readiness measurement. And I explain from the following point of view. One is core network and applications, access network, users, product, and government IPv6 service. Okay, first measurement is IPv6 allocation prefix in Japan. And as you can see, allocated prefix and announced prefix and active prefix are increasing. So this number shows the last time I presented here, and this is as of 2nd of September. So as you see, the number is increasing. And next measurement is IPv6 penetration rate in the internet backbone. This is the number of IPv6 enabled transit areas in the BGP routing table. And this is Japanese average, and this is the worldwide average. And as you can see, the Japanese average is a little bit higher than the worldwide average. And next measurement is consumer service penetration rate in Japan. And here I introduce the ISPs using NTT East and West Internet Access Platform, and also provide information about the KDDI. This is one of the biggest carriers in Japan, and the Tube Telecommunication Network's IPv6 status. I'll show you the number of IPv6 users of these services. Before that, I'll explain why we choose this. Choose the NTT's East and West network measurement. This graph shows the number of fiber service. This graph shows the total IP internet service in Japan, number of subscribers in the fixed broadband access. And their red line is total users, and their blue line is their fiber users. As you can see, it's almost over 70% is for fiber users in Japan. And in this 70%, this is the fiber market share of the fiber service, and NTT East and West occupied almost over half of the market share. So we measure mainly this part of the IPv6 penetration rate. So, and this is the IPv6 consumer service penetration rate in Japan of the NTT's service platform users. As you can see, recently, almost 10% users are dual stack environment. And as you can see, this is the total number of subscribers. So a lot of users is now using the IPv6 and IPv4 dual stack service. And also, this is only the penetration rate, not the number, but KDDI service is already migrated to the IPv6 dual stack environment. Total users are now using the IPv6. And also the CTC, this is a local carrier of the center of Japan, and their IPv6 users are also increasing. Okay, next, this is the traffic to the Google servers. As you can see, the KDDI is the top in Japan, and actually, this is the percentage of the traffic rate compared to the IPv4. So as you can see, so many traffics is IPv6 now. And next, this is IPv6 user penetration rate measured by Akamai and APNIC and Google. And this green line is the APNIC data, and this blue line is the Google data, and red line is the Akamai data. And as you can see, totally over 10% is the IPv6 traffic from Japan now. Okay, next graph shows the IPv6 penetration rate of the web servers. And also, this is the Japanese average, and this is the worldwide average. As you can see, from the content point of view, Japanese average is so low, so small compared to the worldwide average. This is one Japanese problem. Okay, next graph shows the IPv6 support.jp domain name servers. As you can see, the number of servers are increasing. Okay, next slide shows the Japanese government user service. And this is a percentage of IPv6 enabled services. And as you can see, the number is increasing. Okay. So actually, in this web page, we can see that not only the number of service, but also the service health status. For example, this red shows not support, IPv6 did not support, do not support, and yellow part shows something wrong with this service. Yes, you can see such kind of health status of the service. Okay, next is the number of products with IPv6 ready logo. And as you can see, the number of products are increasing, but recently there are not so many applications of this logo. Actually, in this area, Taiwan and the United States is so active in this area. Okay, this is summary. In Japan, as you see, IPv6 connectivity has deployed smoothly, but we have to tackle to improve the content area. But the good news is recent announcement from Apple, IPv6 promotion on the iOS. Actually, we have many Apple iOS devices in Japan, and Apple's announcement that iOS will support IPv6 only environment, so many content providers will prepare to implement IPv6. That's I hope, yes. Okay, this is the end of my presentation. Any questions or comments?
I have one question.
Yep.
It seems to me most of your IPv6 statistics are increasing. So,
Yeah.
So how about the user availability in Japan?
Sorry.
User availability, IPv6 user availability, such as the Google or the Google has survey and the APNIC survey.
Sorry,
From the user's point of view.
Number of users?
IPv6 user availability. No problem. So you have no statistics about the...
Sorry, number of IPv6 users, subscribers?
Yes.
Yeah. Yeah, actually, recently we have so many increasement in that area. This is, sorry, the number of subscribers. For example, currently, NTT's internet service has the maybe 160 million.
Okay.
Oh, yeah. So, and the 10% of the users is already IPv6 enabled.
Okay.
Yeah.
Any other question? Okay, thank you very much, Fujitaki-san. Thank you. Here's a souvenir for you. Fukizaki-san, one moment. It's a souvenir. Thank you. Thank you. Thank you. Thank you. The next speaker is Jessica Shen from APNIC. She will talk about the IPv6 deployment in China. Jessica, please.
Hello everyone, I'm Jessica Shen from APNIC. I'm glad to have the chance to share with you some information on the IPv6 deployment status in China. First, let's have a look at the IPv6 measurement on China by others. On the right hand, it is is a measurement on IPv6 enabled networks provided by REP-NCC. According to the data, 16% ASEs in China have announced IPv6 prefix. And on the left hand, it is IPv6 measurement provided by Cisco. I selected some measurement data from it. You can see from here. In China, we have 11% of routable IPv6 prefixes, and the IPv6 transit AS is about 17%. For regard the content, the percentage of web pages available on IPv6 is about 3%. Okay, here I'd like to introduce IPv6 development in China in such 4 aspects: policy, environment, network, content, and user end. Let's start with policy environment. The Chinese government has released a series of policies on promoting IPv6 since 2010. Well, here I'll only list latest one. It is called the opinions on promoting the development and the application of IPv6 in LTE network. It was issued by Chinese government by the end of last year. This policy aims to accelerate the commercial use of IPv6 on the mobile internet by ensuring new LTE networks support IPv6, ensuring VoLTE adopts IPv6, and accelerating IPv6 adoption for mobile applications. And CNGI refers to China Next Generation Internet. So CNGI project is a very large project driven by the government. It has already, I think, over 10 years history. The largest IPv6 only network in China, CERNET 2, was established in 2004 under the CNGI project. And I think Professor Ma Yan, who is there, is deeply involved in the CERNET 2's construction and operation. During 2013 and 2015, a number of sub-projects under the CNGI project have been implemented, focusing on the following areas: backbone network and MAN, data center, website, application system, CDN, DNS, and equipment. Oh, sorry. Let's move it softly. Okay. Here, commercial network. Here is a summary of the commercial network development status in China, especially the 3 Tier 1 carriers. Their backbone network, MAN, and access network can largely support IPv6. Most network equipments can support IPv6. The IoT network, driven by the government, actually the carriers have done a lot of work on the LTE network. So the LTE network can support IPv6 by default. And the dual stack is the dominant mode in the network deployment. And IPv6 capable users are in China around 30 million, but less actual IPv6 users, because some terminals of the users, like home gateway, can still not support IPv6. In some pilot cities, the carriers set dual stack as the default for new access users. And they still keep working on reform and upgrade of their own data centers, O&M systems, 3A system, and DNS. Here is some IPv6 deployment data from one of the carriers, China Night. We can just have a quick view. So they have 2 backbone network. One is fully support IPv6. The other one supports IPv6 by 6 VPE. And for the MAN, up to nearly 60% network deployed dual stack, and for the ID for the data center, about 50% have been set with dual stack. IoT networks support IPv4 and IPv6 dual stack by default, and the IoT dual stack users reach 2.5 million. After the carriers, let's have a look at the ISP's situation. Founder-BN broadband network is ISP in China who has deployed IPv6 in their whole network. They request a /32 IP address block from IPNIC, and they provide IPv4, IPv6 dual stack access service in 2 cities, that is in Beijing and Tianjin. Their users are PPPoE users with home gateway as a access tool. BRAS sets 2 address pools and give. That's about their assignment policy. BRAS sets 2 address pools and gives 2/16s to a home gateway, one for interconnection, another for further assignments to the devices in the home. Okay, let's move to the content part. Let's have a look what's going on with large content providers in China. Tencent and Baidu adopt a fast deployment approach, allowing IPv6 users to visit large amount of IPv6 content. They use dual stack tech and along with Night 6s and reverse proxy. The they have a few websites supporting IPv6 visiting. You can see the websites include IPv6.baidu.com, pan.baidu.cn, qq.com, qzone.com, qq.com, t.qq.com. Such websites can support IPv6. Regarding the application design, they are aware of avoiding hard-coded IP addresses. Actually, they met some problems in this area because they have hard-coded some addresses in their application software before, and it's hard for them to upgrade it to IPv6. So they have aware of it and do that strategy, and they all have the expertise on IPv6. When it comes to content, we can't skip CDN. China Net Center's CDN platform is a typical one. They support IPv6 regardless of the CP's origin and end user with either IPv4 or IPv6. So in this way, their service can support 4 modes. IPv4 users visit IPv4 content. IPv6 users visit IPv6 content. IPv4 users visit IPv6 content, and IPv6 users visit IPv4 content. It's 4 modes. What they actually do makes it easier for the websites and the user ends to be exposed to the IPv6 world without too much IPv6 upgrade work. Sorry. Okay, let's further look into the observation from the China Net Center according to their IPv6 traffic, which is interesting. On the left hand, it shows the IPv6 traffic from different networks. IPv6 traffic here refers the IPv6 users visit IPv6 content over IPv6 network. So through the from this chart, you can find that more than 60% IPv6 users still come from Cernet. That's the education network. And China Net, China Mobile, and Unicom, the three carriers network, are following the Cernet. They have some relatively large ratio of the IPv6 users. On the right hand, it's Windows 10 download traffic. Microsoft chose China Net Center as Windows 10's release platform. And according to the data, the IPv6 download traffic is only about 1.1%, not very impressive. Okay, still look at content from the DNS perspective. IPNIC is the operator of the .cn and .zhongguo, the CCTLT, and we have 18 global DNS nodes, and 5 of them support dual stack. They are located in Chicago, Dallas, Amsterdam, Beijing, and Hong Kong. The top-level domain has fully supports IPv6 by dual stack, I think since 2004. And the .cn IPv6 recursive queries ratio is 8%. Let's move the final part, the user end. In general, on the smart user end devices like home gateway, cell phone, tablet, laptop, network, printer, and storage, haven't well support IPv6 on the whole. But the terminal chip with LTE mode performs better support to IPv6. Dual stack is still the mainstream mode for the terminals, while in some trail places IPv6 only is adopted. We still keep track on the new tech development on IPv6 in the globe, and I look forward to hear your experience here too. Thank you.
Any question? I have one question as to you mentioned the hard-coded IPv6 address issue. So do you have any strategy to help the ISP, to help the content provider to avoid the hard-coded IPv6 address?
We advise them about this problem through some platforms, such as the IPNIC IP conference just held in last month, we through some platforms and
Do you have some education or some educational content to mention about the hard-coded IPv6 address issue?
There is no requirement. Currently there is no requirement for that. But
Okay.
but the top content providers have been aware of this problem. So we want to convey their concerns and their problems to the larger. To the rest of the content providers, so they can avoid to do that.
Okay, thank you very much. Thank you.
Thank you.
Here's souvenir. Jessica, thank you. And our next speaker is Sengwei Guo from APNIC. He's going to talk about Taiwan IPv6 measurement. Sengwei, please.
Hi everyone, I am Sengwei Guo from Taiwan Network Information Center. Today I will introduce the Taiwan IPv6 Readiness measurement. This is my today's outline. I will introduce the two topics. One is the ISP IPv6 service availability. Another topic is the IPv6 service availability. Finally, I will make the conclusions. This slide explains why, as we know, facing the IPv4 address erosion, and IPv6 deployment is a long-term solution. But many ISP user availability are still too low. So we use the three measurement criteria to investigate the user availability of the government domain, academic domain, and the commercial domain of CCTLD. This slide shows the internet operation diagram. Content provider provide the service such as web, DNS, and email, and so on. And the ISP provide the SS network, such as ADSL, cable, fiber to home, Wi-Fi, 4G, and 3G. If an end user how to use IPv6 to connect IPv6 website, the content provider must IPv6 enable. And the ISP core network and the SS network also support IPv6. We use the three steps to measure the ISP IPv6 services availability. In the step 1, we use the IPv6 allocation and the BGP advertisement to measure the core network. If the AS number announce IPv6 prefix, then we will go to the step 2 to check ISP's AS router and gateway. If the ISP's SS device support IPv6, then we use the user availability to measure the ISP's IPv6 the status. And now I will explain the detail. In the step 1, we use the IPv6 allocation and the BGP advertisement of the core router and the border router to measure the core network. We assume the owner of AS number can classify governmental domain, academic domain, and the commercial domain, and use the percentage of AS numbers that announce IPv6 prefix and the source from global routing table. If the ISP announce IPv6 advertisement, then the core network support IPv6. If the ISP did not announce IPv6 advertisement, checked, and then the core router and the border router. In the step 2, we survey the governmental domain, academic domain, and the commercial domain IPv6 capable of SS services. We conduct a survey by questionnaire. There are 6 different major. There are 6 different major access services, including fiber to home, ADSL cable, Wi-Fi 3G and 4G, and to know the status of IPv6 capable of LAN SS router and gateway, such as broadband race, CNTS, Wi-Fi gateway, GGSN, SGSN, S gateway, and P gateway. In the step 3, we use the APNIC user availability data to check the user availability of ISP. We set up the threshold to find the top 10 ISP with high user availability. If the ISP user availability is too low, check user network equipment. This table shows the status of the IPv6 allocation and the BGP advertisement in Taiwan. The governmental domain, academic domain, and the commercial domain of IPv6 allocation and BGP advertisement. The Taiwan IPv6 allocation and the BGP advertisement ratio is 34.62%. The ratio of the governmental domain is 100%, and the academic domain is 29%. Commercial domain is the 34%. We can find out the status of the IPv6 allocation and the BGP advertisement in below. GSN have only one AS number, so it is easy to reach 100%. Since the academic network use the hierarchy threshold and has 32 IPv6 address, so the major academic network has announced IPv6 prefix. Some major commercial domain have announced IPv6 prefix. Now, in order to know the status of the IPv6 SS router or gateway availability in Taiwan, we conduct a survey by questionnaire to check whether ISP Internet SS services device is IPv6 capable in August 2015. Among 60 LOIR, 48 LOIR provide wireless Internet SS service. In the result, the LOIR SS network device of 4G, there are 100% IPv6 capable. And the SS device of fiber two home are 77%, and the SS device of the cable are 71%. We find out the IPv6 SS router and gateway availability are as following. Regarding IPv6 promotion, to provide IPv6 Internet access service in the most concern for providing Internet access service, IPv6 capable access router or gateway is a must. Governmental domain and the academic domain access router gateway can support IPv6. Most commercial domain access router gateway can support IPv6. This table shows the status of the IPv6 user availability in Taiwan. The ratio of Taiwan's IPv6 user availability is 0.58%, and the governmental domain is the 1031%. Academic domain is 9.12%, and the commercial domain is 0.35%. We also list the status. We also list the top 10 of the user availability in Taiwan. You can find the academic domain is the highest, and the commercial domain is the low. The academic domain use IPv6 voice over IP services to deploy every school IPv6 network. So the IPv6 user availability is higher than others. And because IPv6 user availability in Taiwan is mainly academic domain basis, during every winter and summer vacation, the IPv6 user availability rate was go down. Government domain user availability goes smoothly. Some ISP provide IPv6 access service, but they don't provide it by default. So the ISP IPv6 user growth is low. Now I will introduce the IPv6 service availability topic. In this topic, we made the following hypothesis. The ratio of the IPv6 web service availability for popular web services is at least higher than X of the overall web services for any CCTLD. The gap will slightly decreasing every year. The hypothesis can be used to predict the IPv6 service availability of a certain CCTLD in the next few years. Now I will make the conclusion. To find out the root cause of the low user availability, we use 3 measurement criteria to investigate the user availability of the governmental domain, academic domain, and the commercial domain of CCTLD. We use the 3 steps to find ISP IPv6 service availability and find out why ISP IPv6 user grows slow. Thanks for listening. That's all for my presentation. Thank you.
Any question? No? Thank you, Sengwei. Thank you. It's a souvenir. Thank you. Our next speaker is Jiawei Zheng from Zhonghua Telecom. He's going to talk about Zhonghua Telecom IPv6 measurement and deployment. Jiawei, please.
Okay, thank you. Hello, everyone. My name is Jiawei Zheng from Zhonghua Telecom in Taiwan. It's my pleasure to hear and share our IPv6 deployment experience. This slide shows my outline. The Zhonghua Telecom is the ICT leading in Taiwan. We are an integrated telecom operator. We provide broadband network and mobile service and other internet service. For example, like IDC, web hosting, etc. This page shows the IPv6 measurements in Taiwan. As you can see, the IPv6 ranking in the world list is very low. The result is expected because our company, in our company case, we do not turn on the IPv6 by default. The reasons we will describe later. This is our ASN number measurement in Taiwan. As you can see, we have two ASN number. It's the IPv6 percentage is almost about 1%. It's very low. Next topic, we will share our deployment state of Zhonghua Telecom. The milestones in Zhonghua Telecom, the Zhonghua Telecom has begun to test IPv6 in 2008. We have to participate in the World IPv6 Day and the World ICPS launch in 2012. Now in our company, we are deploying the trial IPv6 in our broadband network. In the future, we will focus on the public wireless LAN and the 4G LTE, especially the voice over LTE is our major plan. In the deployment stage in Zhonghua Telecom, as the Sengwei mentioned before, our backbone and access network is IPv6 capable. And our international networking and the domestic connection, there are many partners and provide the IPv6 connectivity with us. This page shows this page shows all PUBs support IPv6 dual stack service in our company. And this page shows our international exchange and the domestic exchange with our partner. The point is the IPv6 connectivity is not equal to the IPv4. We have seen some problem in this case. This page shows our architectures. As you can see, we have provided the dual stack IPv6 dual stack backbone network, and our access network is also provide the layer 2 transportation for our customers. So, we have also provided some dual stack service. For example, our high channel, our email, our e-advertisement. We have 4 types of service in Zhonghua Telecom. we are focused on the fiber to the home IPv6, IPv4 dual stack service. Our HiNet is concurrent in pre-commercial fiber to the home service stage, but we found some critical issues when our customer, they are using IPv6. So we will discuss the problems later. And we also provide some like DNS, hosting, email, and extra. These services are all IPv6 ready. In Chunghwa Telecom, we also provide the IPv6 testing service. We are we have established in 2003 the IPv6 logo Accurate Lab in Taiwan. We have the test capability include IPv6 core, IPsec, especially we are focused on the CE router now. We have many partners with the test item. For example, like Zycel, like D-Link is a local vendor in Taiwan. Well, the next topic I will introduce the IPv6 experience. I hope we can share this experience with you. In this case, we found the IPv6 routing problem is very critical issue. This question is the IPv4, IPv6 connectivity is not equal to IPv4, so this may cause the user that this is an example. The IPv4 and the IPv6, they have different routing paths. This will influence our customers' quality of experience because their IPv4 and the IPv6 traffic is in different paths. So in this case, they access the same Yahoo in Taiwan, but use IPv6, they take a long time. This will influence the customer QoE. In case two is DNS problem. As we understand, the DNS is a very important system, especially for service provider. But the client prefers IPv6 over IPv4. It means twice the load on the DNS, especially for the OS now, like Windows 7, 8, 10, or the Apple OS. They are all IPv6 turned on by default. This will influence, this will did the loading of the DNS service. So for ISP, our CAPEX is added. We need to add more DNS service to share the traffic load. Case 3, we describe the fallback problem. This problem is caused by the partially deployed environment. We can see this problem is especially significant in TCP-based application. In other words, when users they are browsing the internet website, they will find their QoE is low when they are using the IPv6 because maybe the service provider did not provide the IPv6 access. Maybe the server is not IPv6 ready. These two reasons will cause the fallback problem. The next case, CPE IPv6 issue. We found a very important issue. not all customer private edge support IPv6. All customers, they can buy their own customer provided edge. This device is not controlled by the ISP. So there are two issues we'll ask in this case. The first issue is the end user CPE does not support IPv6 over PVPoE. For my company, we provide we use the PVPoE, IPv6 over PVPoE access for our customer. If our customer, their CPE did not support this function, it don't work. Issue 2, the IPv6 MTU advisement on Ethernet interface should be 1,492 bytes in PVPoE environment. We found, in this case, in the MTU, in the CPE, our customer, they need to set up these parameters. The WAN side and the LAN side are different size. This will cause the link broken. In summary, we found there are some problems in the IPv6 in this broadband, in our broadband network, which are enough to give a bad impression to customer. For example, like routing paths, DNS plan fallback, or by their own CP devices. The ISP and ISP should ensure that the equipment, the software they purchase is IPv6 ready. For ISP point of view, we think deploy the IPv6 is the responsibility of our ISP, because the user, they don't need to know what protocol they are using. And the transition from the IPv4 to IPv6 will be a significant network coverage and a milestone in the history of the internet. The Chunghwa Telecom will provide the fiber to the home-based dual-stack trial service, and we will becoming an IPv6 ready is a key part of China Telecom plans for wider 4G LTE and PWLAN network deployments. Okay, that's all my presentation, and thank you for your attention.
Okay, any question? You have, yes.
In Chunghwa Telecom, what's the traffic between IPv4 and IPv6? The ratio, for example, how many traffic for IPv6, how many traffic for IPv4?
In our Chunghwa Telecom, the IPv6 is in trial stage, so we do not provide the default IPv6. But maybe I can show our customer is less than 10,000. So it's the traffic is not very high, because we found some problem, just as I mentioned.
Any other question? Yes.
Kenny Huang, Executive Council Member of APNIC. Because Chunghwa Telecom have been providing service almost for 5 years or 4 years, and any critical challenge from providing that kind of service, because it seems the service, the traffic didn't grow very well. Thank you.
So, you ask a good question. For the ISP point of view, we think the CapEx and the the CapEx, QoE, and the business model is the important problem for our ISP. We think these three reasons is important for all ISP. For service provider to provide a friendly internet service for our customer is our responsibility. But for business case, you need still concern the investment cost and what we can earn the profit from our customer. This is also another problem for service provider.
I'd like to add one comment. So, we will form a committee, a task force, including several major ISP in Taiwan to talk about the issue, how to help the commercial ISP to promote IPv6.
Sure.
Okay. As you mentioned before, you have highlighted several important issues. Do you have the solution or only the partial solution?
Well, you ask, this is also a very important question. For now, the best solution is we maybe ask our customer, turn off your IPv6. For now. For the future, we hope our environment is IPv6, IPv4 ready. This is our future work.
Okay, thank you very much. Thank you. I'd like to end this section, so please join me to thank all the speakers once again. And I'd like to pass the microphone to Miwa. Thank you, Miwa.
Thank you. No, thank you, Professor Chen. Thank you very much. All right, welcome to the IPv6 task force. Now we're going to have a task force session. First of all, just to quickly explain what this BoF and task force are doing. The BoF and IPv6 IPv6 readiness measurement BoF and APIPv6 task force has been collaborating together by co-hosting this meeting at every APRICOT and APNIC meeting since 2012. And the BoF focuses on statistics, and the task force focusing on anecdotal evidence stories about IPv6 deployment. So we have 5 speakers, and the first speaker is from Australia. He's going to remotely log in, Mike Biber, the acting chair of APIPv6 task force. So let me go back to the Skype and talk with him. So just give me a sec. Mike? Mike, can you call me?
I'm talking to you now.
Okay, he's connected.
Good evening.
Can you speak? Hi, Mike.
Hi, Mila. I can hear you. Can people hear me okay?
Yes, we can hear you very well. Please go ahead.
Okay, that's great. Thanks. You'll do the slides for me. So combined Asia Pacific IPv6 Task Force BoF and also I hope you're having a good time at to join you. Australia update. There's just a few comments I'd like to make. Go through pretty quickly, and we can go on from. So, you next, please.
Next slide, please.
I was going to a bit about all of you are very familiar with what's happening with the regional internet registries and the company. And I want to talk about some things that are developing with the Internet of Things. So, about this, and all of you be pretty familiar with some of the things.
Mike, we cannot hear you now.
I'm talking to you now. Okay, I can hear you. Okay.
We cannot hear you well.
Yeah, no. Hey, I think I can see the video. I don't know if it's actually frozen or not. Have you moved on? Can you hear me? To you now. Ah, okay. I just got a small screen refresh. Can you hear me now? Hello?
Yeah.
This might be a problem, I think. I'm sorry. You can't hear me?
Yeah, we can hear you now. Please go ahead. Sometimes
okay,
we lose you. Sometimes we lose you, but now it's okay. So please go ahead.
Okay. Yeah. If that keeps happening, then I'll stop and we can move on to the next speaker. So I can still see the slide. Have you moved off that one? That's right. And in fact, you're all familiar with the what's actually happening. This is the latest graphs from Potteroo and APNIC on what's actually happening with the exhaustion. It is interesting that there's been recovery of IPv4 addresses from a number of different places, and this actually does have an impact on the final exhaustion of the remaining pool that has been allocated. It's interesting also to see the rise of the IPv4 brokers, and it's something that I'll have another slide on. So I'll move on to the next slide. Just I want to go through them quickly. You're all familiar with the various measurement tools that are actually out there from Cisco and Google, Akamai, and the ones that unfortunately I wasn't able to hear the previous presentation, but I know that there was some interesting presentations planned on this. But we're seeing significant exponential growth in IPv6 access, either measured as content provision or measured as raw data on the internet itself. And we're seeing this traffic double in some geographies much faster than every 9 months, but generally, that is a lot of adoption. Next slide. Okay, there are two slides that actually follow here. It's blank at the moment, but the first one, if you could just press the mouse once. If we can see that. Hopefully the transitions are working. Okay, this is I think the adoption from last year, and we've seen, this is just Google's statistics on the number of people that are actually reaching Google in IPv6 from Australia, and you're familiar that this is available for most countries around the world. But just looking at the Australian pattern, if you click again, you'll actually see the figure from, I think, yesterday. So can you click one more time, please? There we go. Sorry, it jumped too quickly. Sorry, they both came up. That's it, thank you. That's really just an overlay of the figure, I think, from yesterday when I finalised the presentation, I think. But we've actually seen growth now up around 1.48%. It's not huge by world standards. The average world standard on the Google graph is about 9%, just short of 9%. Some countries are much, much higher than this, but it is showing a doubling and a steady progression. If we can continue. And again, that's the APNIC graphs. I won't talk through that. They're all available for you to actually have a look at. So we'll go, just for the sake of time, if you could click one more time, please. That was actually the graph from last year and the graph from this year. Click one more time. Okay, IPv4 resale is actually growing dramatically. You've seen the numbers. There's been a number of articles about the range of cost recovery. The fact there is a market for IPv4 shows the the value potential for IPv6, and that there is a business case, a financial business case for people adopting IPv6 to avoid these costs that are emerging in IPv4. Major telcos around the world are actually buying up IPv4 space, and we've seen this in Saudi Arabia, Iran, and a whole range of other countries, and now there's a whole lot of businesses that have become established. Fornow.com is based in Australia and it's actually operated by Intelligo. There are a whole range of other ones that are emerging around the world to satisfy this, and this is providing an incentive, and people picking up on this. People that we talk to in the Australian marketplace are picking up on the fact that there is a financial incentive to actually move to IPv6 now, and that's expressed in a number of different ways. If we could go again, next one. Australian status. Interestingly, there's been more and more people adopting IPv6 in Australia, but in fact the status of our service providers is about the same as it was 6 months ago. There's been no dramatic new announcements, I don't think, of any new ISPs who
Mike, we are losing you. We lost your voice.
Are offering service, but there are people who are doing it by stealth. They're introducing it in, not making big announcements.
Mike, we cannot hear you. Mike? Yes. We cannot hear you. Mike, we cannot hear you. Okay. Right, so sorry Mike, we kind of lost you. Sorry, we cannot hear you. Cannot hear you anymore. So the Mike's presentation are remaining 3 or 4 slides. You can download his presentation and take a look at it. And if you have any questions to Mike, please let me know. I can link you to Mike. So Mike, thank you very much for participating from Melbourne through remote participation too. Sorry we couldn't finish your presentation, but your presentation is uploaded already, so everybody can have access for that. Right, we're going to move on to the next speaker. Next speaker is Romy Kuntro from Indonesian ISP, CBN. Romy? Yes.
Thank you. I'm Romy from CBN. Let's start my presentation. Okay, let me introduce who is CBN. CBN is an ISP that started at 1996. Our OS number is 4787. And we have an NAP license since 2008. And currently we have 8 branches in Indonesia and more than 200 POPs in around Jakarta, like at commercial mall and apartment. And currently we have 2,000 dedicated customers and more than 25,000 retail customers. That is CBN. So here is our IPv6 milestone. So at 2003, we are the first ISP in Indonesia that received IPv6. At that time, we don't know what to do with IPv6. So the first deployment, we start from Googling. Sorry. Thank you. So, and started 2004 until 2006, we doing the IPv4v6 tunneling. So, and then we also deploy IPv6 dual stack in our backbone. So at that time, we start IPv6 and IPv4. Starting 2007, we do some trial with IPv6 L2TP. So at that time, we do some presentation at Apricot 2007 in Bali. And then we also do a dual stack exchange at that time. Starting 2008, we have our POP in Singapore. We do dual stack IP transit. 2009, 2011, at that time we starting using a PPPoA dual stack trial. It's not successful, and then we delay the deployment until 2012. We're starting the deployment for the dedicated customer, dual stack. And then 2013, we start our second trial for PPPoA dual stack with DHCP-v6 PD. And we also get assessment from the government, and we start deploying our broadband dual stack in Bandung, Bali, and Bogor. Starting 2014 until now, we implement IPv6 for broadband Jakarta because the most bigger users for us in Jakarta. Then what we learned in 12 years. So the first is there's a delay from our vendor to provide the features that we required for our development. So the second thing is there still need a lot of standard feature for IPv6 for the CPE, because we see that there's a lot of CPE that is not standard feature, and we also need some support fund for our shareholder. Third thing, and then some of our customer is not ready to implement the IPv6. So at that time when I discussed, the customer still consider about the security issue. So then we still a lot need support from the content provider for implement their IPv6, because we see that in Indonesia there's many content provider that don't want to use the IPv6. Maybe they're scared about the security. So, and the customer also didn't aware about IPv6. That's also a big challenge for us. Okay, so the customer is, as long as they're connected to internet, they're already happy, so they don't aware, is it IPv6 or IPv4? So this is how we assign IPv6 to our dedicated customer. So we allocate the IP point-to-point /126, and then we allocate /48 for them. So they will put CBQ bandwidth shaping at the interface, and then we implement the IPv6 ACL. And this is for the IPv6 broadband allocation. So we using dual stack PPPoE. So when user try dial a PPPoE, they will get IPv6 and IPv4. And then the next is we implement our Readiness API. So we match the IPv4 and IPv6 in the one profile. And then we allocate the /64 for each customer. So in our Readiness, we already implemented. If this customer, then we get a dedicated IP address. At the CPE, that is depend on the customer. So the customer can buy what kind of the CPE they like, as long as they're supporting the PPPoE. So how we support the implementation of IPv6? So actually we do an automatic assign IPv6 to our broadband customer. And then we are supporting a Quad A query in our DNS. So actually that we never told the customer that we ready for IPv6, but we just give them IPv6 when they dial the PPPoE. So this is our traffic at the moment. So we see that from May to August, there's some increase. Maybe very small for us, something like a 20 meg, but it's a good start, I think. So I think that's all for my presentation.
Thank you, Romy. Do you have any questions or comment? Okay, I have one question. Romy, what do you think about, what's your observation about the general trend of Indonesian ISPs and telecom operators on IPv6 deployment?
Actually, the trend is getting more ISP to use IPv6 to delegate to the customer, but there's still some challenge. Maybe from the network side, and this is depend on it's because the government only encourage.
Thank you very much for your presentation. Thank you. This is a small gift. Thank you very much. Thank you. Right. Our next speaker is Masataka Mawatari-san from JPIX. He will talk about most recent 464X LAT deployment. 464X LAT RFC. Yes, thank you.
Hi everyone, I'm Masataka Mawatari from JPIX, and today let me introduce the progress of IPv4 over IPv6 standardization in the IETF. This slide is an introduction. This presentation introduces your timeline for publishing RFC. Today, for example, RFC 6877 464X. And IETF 94 meeting will be held in Yokohama, Japan in November. I hope that more people will participate and discuss there. This presentation is agenda there. Firstly, IETF introduction. IETF is a large open international community of network designer, operators, vendors, and researchers. But what is difference point between network operation group and IETF? Two organizations have different purpose. The purpose of NOG is sharing technical and operational issues, and the purpose of IETF is proposing and standardizing solution. This slide shows IETF organization structure. ISG team is handling 7 areas now, and each area have a working group. Today, the number of working groups is around 130. Next slide is RFC standard process in the IETF. All of document start as an individual document. The individual document changes to working group document to RFC based on consensus in each discussion place, working group or IESG. Some years ago, the IPv4 by IPv6 proposal is very hot in the IETF. This slide is motivation and uniqueness of 464X proposal. Motivation and uniqueness of proposal is very important thing to move forward the document in the IETF. In the case of 464X, motivation and uniqueness point has 3 points. One is minimal IPv4 resource requirements, and 2 point is no new protocols required, and 3 point is IPv6 only networks simpler. This is the timeline of 464X draft. Firstly, I published the version of 464X in software working group in IETF. And I updated to 01 to 02. And when I updated 02 version, one of course added to this draft. He is Cameron from T-Mobile US. And I introduced in software working group IETF 82 meeting. But I got a comment that 464X is suitable working group V6 Ops working group. So I published the version again in V6 Ops working group. And then the document was approved as a working group document in V6 Ops working group. And I updated the document 00 to 01. And then ITF 83 meeting, I introduced the document. And then I updated document again. And then I updated for the 05 version, V6 chairs said me that for 60X that discussion place changed to sunset for working group. So I introduced in sunset for working group in ITF 84 meeting. But I got a comment from working group member for 64X that should continue to discuss in V6 Ops working group 84 V6 working group. And the 46X that is approved working group last goal and ITF last goal. And then 46X that registered in RFC editor queue and finally published RFC 6877. And conclusion. This slide describes important things to move forward with draft. 3 points, draft consensus and running code, and free considering comments from working group members. It's for communication with members in fairness. And cooperative relationship with co-authors, and it's for constantly checking and sharing a goal to reach with co-authors. And for coming next IETF meeting in Yokohama, I would like to introduce interesting internet draft. 3 drafts in this slide. They are IPv4, IPv6 tech operational experience. Thank you for your attention.
Thank you, Mawatari-san. Any question or comment? Right, I have one question to you, Mawatari-san. What's your thought on the future of the usage of 464 XLAT? Do you have any thought or observation?
GPX also provide IX members 464 XLAT trial service. And we took statistics of our trial service. So probably I can introduce statistics of our service.
Thank you very much. Round of applause, please. Thank you very much, Mawatari-san.
Thank you.
Small gift. Thank you. So our next speaker is Mr. Hai Jun Lee from China Mobile, IPv6 progress in China Mobile. Thank you.
Hi. Hello, everyone. I'm Li Haijun from China Mobile. Thanks for the chance to share our IPv6 deploy experience. My presentation title is IPv6 Progress in China Mobile. My presentation divided into 3 parts. Part 1 is overview of IPv6 progress, and part 2 is our IPv6 solutions and problems, and part 3 is our IPv6 working plan. Our IPv6 progress has 4 main sections. The first is we have finished IPv6 network trial in 10 provinces, such as Beijing, Shanghai, and the second is we have developed over 3 million IPv6 subscribers, and the subscribers included LTE subscribers, Wi-Fi subscribers, and fixed line broadband subscribers. And the third is all our TD LTE terminals support IPv6, and we spend about 200 million China yuan to buy the TD LTE terminals, and the terminals we required all the terminals must support IPv6. And the fourth is about 10 of our own applications support IPv6, such as 139 email box and etc. And this is the IPv6 related network, and almost all the network equipment is related with IP address, and the network include our barrel network, core network, access network, and supporting systems. And we upgrade 800 barrel work equipments and 100 core network equipments, and 400 BRAS, and 1,000 ACs, and over 10,000 APs. So the network upgrade is very large work. Then to the part 2, IPv6 solutions and programs. This is our IPv6 solution for mobile service, and our primary solution is dual stacks, and our GDSN P gateway distribute IPv4 private address and IPv6 address for the terminals. And after the GDSN and the P gateway, we translate, use the NAT44, translate private IPv4 private address to the public address. And another solution is the BIH, and it's similar like 464 XLAT. It's translate in the terminal, translate the IPv4 to the IPv6. And this is our IPv6 solution for Wi-Fi. And as we know, Wi-Fi terminals can obtain IP address before authentication. So they'll result a waste of IP address. So we think IPv6 must be imported to Wi-Fi. And our IPv6 solution is based on dual stacks, and our ACs upgrade to support IPv4 and IPv6 access. And our portal system is also upgraded to realize IPv6 authentication. And the big question of our IPv6 deployment is the applications. And they are not ready. And we test 50 kinds of popular clients and applications running on PC in our lab, and about 76% clients are just developed for IPv4 only. So here is the result, and most of the applications support IPv6 are browsers and mail clients, and other applications such as instant message or online music don't support IPv6. So we think this is the big question, and we maybe the IPv6 and the IPv4 will coexist for a long time, we think. And part 3 is our IPv6 working plan. And this year we will promoting our voice over LTE, and we require IPv6 as a mandatory condition of voice over LTE. And the IPv6 has been included as a basic feature of voice over LTE related network equipment requirements. And we also require voice over LTE terminal must support IPv6. And we will provide voice over LTE users IP addresses in IPv6 only mode. And the detailed work plan is we have 3 periods, and the first period, the task we have finished, and the second period, our plan is to complete network IPv6 transition and start IPv6 commercial deployment. And we want to develop more IPv6 subscribers. And the third period, our plan is to all the increased subscribers and the service can use IPv6 address. And we want all our backbone and the main network can use IPv6. Okay, that's all. Thank you for your attention.
Thank you, Haijun. Does anyone have any question or comment? Right. I have one question then. You mentioned about VoLTE, and China Mobile is planning to make VoLTE over IPv6 only mode.
Yeah.
Do you have an actual roadmap to achieve this goal? Do you have any plan what year to achieve this?
Plan is we will maybe we will voice over LTE commercial this year, and this is the same time the IPv6 will imported.
Oh, that's quite impressive. So we were expecting to see some sharp growth of the IPv6 traffic too.
Yeah.
Thank you very much. Thank you. So this is a small gift from APNIC. Thank you. So our last speaker is from APNIC. Ms. Nguyen Taiwan from APNIC, and she will talk about VN IPv6 Task Force update.
Yeah. Hello, everyone. And I think it's very late, so I have just a quick update First of all, I would like to introduce myself. I'm from VNIC in Vietnam. As you know, VNIC is a standing committee of the Vietnam National IPv6 Task Force. So in my presentation, I will going to talk to you about 4 topics, including National IPv6 Task Master Plan, IPv6 deployment activity, Vietnam IPv6 ready measurement, and upcoming activity we will have in the future. And first on, as you know, we have 3 places in National IPv6 Action Plan, and this year we are at the end of the implementation phase. We focus and we would IPv6 in Vietnam transition from IPv6 network, support IPv4 and IPv6, and we also would like to provide test IPv6 service to end users. And as you know, just last year we have just IPv6 master plan. We add more than organization company to into our master plan. Not only ISP but also software enterprise, equipment manufacturing enterprise, register.vn, and content service provider go to action with with ISP and with Vietnam government. Then I going to next I going to talk to you about the IPv6 activity this year. As you know, Vietnam IPv6 Day. This year we held the Vietnam IPv6 Day conference on 6 May 2015, and we had more than 100 participation. They're talking about IPv6 application for mobile broadband. Yeah, if you are interested in Vietnam IPv6 Day conference, you can go to the website. Yeah. And this slide, I would like to focus on the IPv6 activity this year. Vietnam IPv6 Task Force work with 7 enterprises for mobile, ISP, and content. For example, VNPT, Viettel, or FPT. And about content, we go to VietnamNet.net and VNExpress.net. Yeah. After that, we're very happy to know that Viettel and VNPT were ready for support IPv6, and they also have plans test IPv6 on end user. Yeah, so test on the small group customer at the end of this year or in the first quarter of the next year. Yeah. About content, as you know, content have just come to Vietnam Master Plan, so they also have a plan for transition to IPv6 in 2 years. ISP it's good news that almost big ISP in Vietnam are ready for IPv6. However, they did not deploy IPv6 on end user. However, FPT, for example, FPT Telecom is a very good deployment IPv6 to end user. Today they have more than 90,000 customers using IPv6, and they hope that the number will increase to 100,000 people using IPv6. Yeah. And other activities regarding to IPv6 in Vietnam, we also focus training cost. Yeah, we VNIC and Vietnam Internet Association have basic training course for managers. Also, we Vietnam IPv6 Task Force and government officer of Party Central Committee have the advanced training course for technical team. And also in now and in the future, we also focus training for IPv6, not only for manager, especially we would like to focus for technical team. Yeah, I would like to you can know more about IPv6 measurement in Vietnam. As you know, the Vietnam National IPv6 Network, so we need also to take care of the National IPv6 Network. So, as you know, we support IPv6 and IPv4. And also, there are 10 ISP connected to VNIX, and 4 ISP have an international IPv6 connection. Yeah. And now we can you see in the slide? So, by the last fiscal, we have a Vietnam IPv6 development has some information. We get 10%, yeah, more than 10%. Good. I think the IPv6 transit and content is a good number, so you can see end user. As you know, many in Vietnam, not much ISP deploy IPv6 to end users, so you can see Vietnam has just, I think it has just more than 1% people using IPv6. So we very hope that in the future the number will be increased by Vietnam IPv6 activity in now and in the future. And now is a slide about the IPv6 status by Google. And upcoming activity, we also like to increase the number of end users in Vietnam can using IPv6. So we also to have plan to learn experience IPv6 deployment in an advanced country at the end of this year. So also we focus IPv6 training cost, and anniversary Vietnam IPv6 Day will be on May 6, 2015. Yeah, that's all. Thank you very much.
Thank you,
yeah.
Ms. Nguyen. Does anyone have any question or comment? Right. Then I have one question to you.
Okay, thank you.
Today we heard a lot about enabling IPv6 in mobile networks.
Yeah.
What's your observation about the mobile network operators in Vietnam? Are they aware about the importance of increasing their awareness about the shortage of IP addresses, not only on spectrum? What do you think?
Yeah. About mobile network in Vietnam, as you know, not much. For example, VNPT and Viettel is the two biggest mobile network provider, but they do not have much using deploying IPv6 onto end users. They just support from a network. Yeah. So after we have a plan go to working with them, they also talk to us, and they have a plan that they will they would have a pilot test IPv6 at the end of this year. And we also have a plan to learn about the mobile network. Yeah, we have a plan go to the advanced country at the end of this year to learn mobile network, and I think the presentation from China, yeah, I don't know exactly his name, but I think it's the good way we can learn from the presentation.
All right,
yeah.
Thank you very much.
Yeah,
right.
thank you.
This is a small gift from APIPv6 Task Force. Thank you very much. Thank you. Well, this concludes for today's APIPv6 Task Force session. So thank you very much for all speakers from BoF and also from Task Force. Thank you also for the other participants in this room to stay back for this late tonight. And also, thank you very much for APNIC's tech team and hotel tech team to stay back to support this BoF and APV6 Task Force meeting. They always stay back on Tuesday or Wednesday night and stay with us. So thank you very much. So round of applause for these guys. Thank you. Thank you. And the IPv6 Readiness Measurement BoF and APIPv6 Task Force will meet again at Apricot 2016 and APNIC 41 in New Zealand. I hope some of you become a speaker and share your interesting information knowledge with us. So see you again in New Zealand. Thank you. Have a nice evening.